Dear user, we recommend you to watch this video where the points to be considered while commissioning the eSmart panel are explained. Rotating shafts, electrical equipment and high-pressure systems are dangerous. In order to prevent injuries, occupational health and safety rules must be followed, and commissioning must be carried out by trained and expert personnel. The area where the eSmart panel and the water booster will be put into use should be away from negative external factors such as rain, frost, dust and sun. It should not be activated with temporary electricity. It should be checked with a voltmeter that the mains voltage is balanced between the phases and that it is within the allowable range of 400 V plus or minus 10% for the eSmart panel. Before starting the electrical connections, the mains energy must be cut off from the main circuit breaker and must be checked with measuring instruments. The electric motor power connected to the eSmart panel should be maximum 7.5 kilowatts. Do not use higher power electric motors with the eSmart panel. The main energy supply cable section of the eSmart panel should be selected in accordance with the total motor power and cable length. Before connecting the electric motor to the eSmart panel, the terminal box of the electric motor must be opened. The connection jumpers must be removed and the stability of the stator windings must be checked with a measuring instrument. After the star or delta connection, which is specified on the electric motor label and suitable for the mains voltage, is made with jumpers, the terminal box must be closed by connecting the cable with the appropriate cross-section for the motor power. Before opening the front cover of the eSmart panel, there should be no dust or liquid etc. around the panel. When removing the screws on the four corners of the front plastic cover of the eSmart panel, be careful not to let the front cover fall to the ground and not to strain the cable in between. After opening the front cover, continue working safely by sliding the cover up and securing it to the upper screw slots of the back box with the lower screws of the front cover. After opening the front plastic cover, thread all cables through the appropriate cable glands and ensure that any unused cable glands are properly sealed. The device must be properly grounded. Connect the main ground wire and the electric motor body ground wires to the ground bus bar. Connect the main power cable to the circuit breaker in the eSmart panel and make sure that it does not come out of the fuse when you pull the cables lightly. It should be carefully checked before energizing that there is no damage or malfunction in the cable between the panel and the electric motor. Connect the wires of the electric motors to the motor terminals. Connect the wires of the pressure switches to the pressure switch terminals. Connect the float switch wires to the float terminals. After connecting all the cables to the terminals, make sure that the terminal screws are tightened correctly and that the cables do not come out of the terminal when pulled lightly. Turn on the circuit breaker inside the eSmart panel. After the electrical connections are made, remove the front cover again and slide it down to replace it. Make sure that the plastic cover is closed properly after the electrical connections have been made. eSmart can be damaged by pollution. Never leave the eSmart with the cover open. Turn on the main energy circuit breaker that energizes the eSmart board. After energizing the eSmart, set low and high current limit values from the menu for electric motor protection for each motor separately according to the motor power. Before starting the current settings, the pump must be bled from air. Open the valves on the suction side and make sure the water is getting to the pump. Close the valves in the discharge line. If the automatic LEDs on the eSmart front panel are active, the automatic LEDs must be turned off by pressing the button. The engine will run as long as the test button is pressed after the automatic LEDs turn off. Remove the bleeder valve. Press and hold the test button until water comes out of the bleeder valve. After the water comes out, close the valve again and release the test button. Repeat this procedure for all pumps. After the pump is bled, the pump should be started by keeping the test button pressed while the valve in the discharge line is closed. When the pump starts, it should be confirmed that there is pressure in the line from the manometer. While holding down the test button, the current drawn by the relevant pump motor is seen on the main screen. For all pumps, the low current protection value should be entered 0.2 ampere less than the value shown on the main screen. Press the Approve button. Enter the menu password with the Up, Down, and Approve buttons. In the main menu, move the cursor to the current settings line with the Down button and press the Approve button again. Enter the Low Current Settings menu. Set the low current protection values for Pump 1 and Pump 2. For example, if the current shown on the main screen is 2.9 ampere when the test button is pressed and discharge line valve is closed, enter 2.7 ampere in the low current protection value and press the Approve button. After the current settings are made, return to the main screen with the Cancel button. After the low current protection values are set, open the valves in the discharge line. The high current protection limit value should be applied according to the full load operating values of the electric motor in the pump system. Press and hold the test button to see how many amps the pump draws at full load. Release the test button and press the Approve button and enter the menu. From the Current Settings menu, the High Current Value menu is entered. Set the high current limit value for all pumps in the system. For example, if the electric motor draws 4.3 ampere while the pump is at full load, the high current protection limit value should be set 10% higher, so 4.8 ampere. After the high current setting is made, return to the main screen with the Cancel button. Make sure that the set high current limit value does not exceed the nominal operating current written on the motor nameplate by more than 15%. It is recommended to apply the current settings according to the values at which the pump set will operate. In electric motors, starting more frequently than the maximum number of switches allowed by the electric motor manufacturers according to the motor power may cause malfunctions. For this reason, the maximum number of switch to be allowed according to the motor power connected to the panel should be set in the maximum switch menu. For example, if the electric motor in the system is 2.2 kilowatt, the maximum switch hour value should be set to 60. After this setting is made, the pump will not be activated more than the allowed number of switches while operating in automatic mode. It is activated automatically at the end of the defined time depending on the set number of switches. In cases such as the failure of the expansion tank, the pump will not be activated very often and the protection of the electric motors will be provided. Fasten up the float switch cable and adjust the working distance according to the water tank. When the water runs out, make sure the float drops and the panel gives water error, and if there is a running pump it will stop. To prevent the pump air intake, set the minimum water level to be at least 50 centimeters above the pump suction port. It should be checked that there is compressed air in the expansion tank. Lack of compressed air in the expansion tank causes malfunctions. The expansion tank air pressure should be 10% less than the pump operating pressure. After all the settings are made, the system should be put into automatic mode by pressing the A button, and it should be checked whether it works properly. During full load operation, it should be checked that no more than 10% of the nominal current written on the motor nameplate is drawn, and when the suction valve is closed, the panel switches to low current error and stops the motor. If the system will work with a pressure switch, the pressure switch settings should be made according to the operating curve of the system. It should be practically verified that the pumps can operate and stop in automatic mode according to the pressure switches. Suction and discharge valves must be open. It should be checked whether the pump can operate and stop in automatic mode. Maintenance should be done at least 3 times a year. Read the user manual for more detailed information. These clauses must be complied for the warranty to be valid.